Welcome to the explainer. So, AI coding assistants are everywhere, right? We're all using them, and they promise to make us so much faster. But what's the real story with the code they're actually writing for us?
That's the big question. And we're going to dig into it by looking at three fascinating new studies. We're going to see how developers really talk to these LLMs, uncover a hidden energy cost you probably haven't thought about, and then see if we can maybe nudge these AIs to write, well, greener code.
We'll kick things off by looking at the quality of the code itself. And honestly, the results are pretty surprising. It's rarely perfect on the first try. After that, we're going to uncover a hidden cost. Something you might not even consider when you hit generate. It's pretty eye-opening. And we'll wrap up by looking at a really promising path forward. We'll explore if we can actually guide these AI models in a more sustainable direction. It's a fantastic question. Okay, let's dive right in. So Theo, when I think about using an AI to write code, I kind of picture giving it just one single command and boom, perfect code. But is that how it really works?
Not really. The research shows it's much more of a back and forth, more like a conversation.
In fact, a huge majority, 68% of interactions are these multi-turn conversations. So developers almost never get the perfect answer on the first go. Instead, they have to refine, clarify, and keep adding new requirements. And this slide just illustrates that difference perfectly. A single turn is what you described. Ask a question, get an answer. But a multi-turn conversation, that evolves. The developer is actually guiding the AIs step by step toward a much better solution. Ah, that makes total sense. So it's like we're debugging the AI's first draft. So what kind of problems are developers actually finding in that initial code?
Oh, the issues are all over the place, and they're often really specific to the programming language. The bottom line is, the code is almost never perfect right out of the box.
Now, what I find really fascinating here is the pattern. Look at Python and JavaScript. The model just hallucinates variables that don't exist. But for Java, it's a documentation problem, almost 76% of the time. And then for C++ and C#, it's usually about missing dependencies. Wow. So how do developers get the AI to actually fix these things in those conversations you mentioned? Well, the most popular method is also the most direct one. Just clearly point out the mistake and ask for a fix. It really shows that guiding the LLM with precise, clear feedback is the key to getting code you can actually use. Okay, so the code usually has bugs that need some fixing. But, once it's working, what's the problem? If it runs, right?
That is the critical question. And it turns out that just because code works doesn't mean it's efficient. There's this hidden cost we're only now starting to measure, how much energy it uses. And this brings us to this whole idea of green coding.
Right. So green coding is basically about writing software with the smallest possible energy footprint. And when you start comparing LLM-generated code to human-written code through this lens, well, the results are really, really telling. This chart is amazing. If we set the average LLM code as our baseline of 100, average human-written code is already about 16% more energy efficient. But look at that third bar. A human expert who is focused on green coding is just in a different league. Their code is consistently 17 to 30% more efficient. That is a massive gap. So it really sounds like human expertise is still absolutely essential for writing truly green code. Is there any way at all to get the AI to close that gap?
There is some promising research, yeah, and it revolves around two key ideas: using smaller, more specialized models, and being way smarter about how we ask them to write the code in the first place.
So the most basic way to do it is called zero-shot prompting. You just give the model a straight-up command. No examples, just optimize this code. The next step up is few-shot. This is where you actually show the model an example or two of what you want it to do before you give it the real problem. And then there's a more advanced technique they looked at called chain of thought. Here, you actually force the model to reason through a plan, to think step by step before it writes the final code. The hope is that this leads to a more thoughtful, more efficient output.
And do these smarter prompts actually work? Do they make the code greener?
Sometimes. And this is where things get really interesting. The research shows that how well a prompt works totally depends on the specific model you're using. This summary is just fascinating. For a model like Qwen, pretty much any structured prompt helps it beat the human baseline for efficiency. But then you look at stable code, and only the super complex chain of thought prompt worked. And for the other two models, nothing. None of the prompting strategies could get them to produce code that was more energy efficient than the human baseline.
So it sounds like the big takeaway is that we're moving past just asking for code. The future might be more about knowing the right way to ask the right model to get results that are not just good, but also sustainable.
Exactly. It's not just about what the AI can do on its own, it's about how we guide it. And that leaves us with a pretty big thought to chew on. As these tools become just a normal part of our daily work, are we going to start demanding that they're not just fast, but also efficient? Thanks so much for joining us for this explainer.
Thank you for listening.